enjoy the cookie. And if they don't go out, we might have to take a second break just to make sure the cookies don't get dry. So, right before they get out, we'll eat their rest. Just kidding. That would be really cool.
No, you're not. I appreciate this.
All right.
So even if you are.
So we were talking before the break. I just wanted to make sure everybody was clear on what they are, the gist of how we would conceptually think about them to create research questions. Now, we're going to go into the nuts and bolts of how to test them in our last hour or 45 minutes or so. So we go to 6. I have an alarm on my phone that will go off at 5:55 because, again, you know, once my SEM class let me go 30 minutes long. I thought class ended 30 minutes later than it really did because I had a different class that was on the half hour and the other was on the hour. And they just all sat there the whole time. And then, wait, we went 30 minutes over. This class starts at 9, not 9:30. So anyway, when I get going, you can just, so hopefully the alarm will help. All right, everyone clear on step 1, theoretically, does it make sense? Step 2, do we have enough power? So that would be, sample size is really one of the very biggest pieces. Our measurement precision is another really big one. All right. Step 3, appropriately code all categorical variables. This happened a handful of times this semester. It happens every semester. So don't feel bad if this was you. But if we have a race variable, which almost all of you do, some form or another, race is normally asked on a single question from 1 to 8 or something like that. You can't use that variable as 1 to 8 because it makes no sense. So 1 unit increase for one race to another is not an up or down. They need to be dummy coded. So if there's 8 categories, we need to make 7 variables where they're all 1s and 0s. So make sure that we're properly coding any of our categorical variables. Step 4, we need to apply a meaningful 0 into our predictor and moderator. Lots of the time, and this isn't always done, but this is more of a best practice suggestion. But because the way we run moderation, it's different. When all of our variables, I'm getting too ahead of myself, aren't I? Yeah, I need to hit it there, never mind. Right now I'll just say transform them. Put them into z-scores is really the preferred way. Some people mean center, which literally means you compute a new variable by subtracting the variable score by the mean. So that whenever you see a 0, that person would be right on the mean, and anything positive is above, and anything negative is below. But it's a little bit better to do a z-score. Then a 1 unit increase is now a 1 standard deviation unit increase, which is exactly how we're going to make our figure. So it's just one step a little bit closer to what we're actually doing. Step 5, make the interaction term, compute it. Step 6, run it, and whatever it is that we're running, just about any stat, you can put that interaction term in there. Step 7, interpret it. So this is where I'm talking about the meaningful 0. So if we have, and I think most of you already know some of this, but if we have a beta, an unstandardized beta of 0.3, we would say is our predictor goes up 1 unit, our outcome goes up 0.3 units on this unstandardized scale of 1 to 5 or whatever it is, while controlling for all the other variables, while holding all the other variables constant. That should sound pretty familiar from some stats class I tried to block out a long time ago. But it's a 1 unit increase in the predictor associated with this unit change in the outcome while controlling for the others. When we add an interaction term into the model, it fundamentally changes the model. So it's now, we have a 0.3 as our beta. Listen for the difference. A 1 unit increase in the predictor is associated with a 0.3 unit increase in our outcome while holding all the other variables at 0. Hear the difference? So now we're holding all the other variables in our model at 0. And if all the other variables at 0, let's say our predictor and moderators are all on scales of 1 to 5 and 1 to 7, then it really doesn't even mean anything. 0 is not even on their scale. So usually we handle that by mean centering or standardizing. But again, standardizing is a little bit better. I apparently have a few more slides on that, but I just said it all out loud. So I think that's good. Does that make sense? So we want to mean center or standardize our variables so that they have a meaningful 0. Also, in M+, it's really handy in the output. We have the stdyx output. How many have used M plus before? So for you, if you've seen this before, the M plus output, there's the unstandardized betas, and then there's the stdyx, which is literally standardized y, standardized outcome, and standardized predictor of y and the x. The next box of output below that is stdy. So if you've standardized your predictors already, you didn't standardize the outcome, you're not supposed to standardize the outcome, then you'll report the output for the stdy, because we're not double standardizing the predictors that have already been standardized. So that helps. In step 8, draw a figure to show what you found. I would really like it if I could have you do this. I don't know a way to help you test moderation on your own because there's no free version of M+, AMIS, or SPSS that allows you to have at least 3 predictors. And to test moderation, we need the predictor, moderator, and interaction term. So M+ only lets us have 2 predictors. So it doesn't work. So I'm just going to walk you through and show you on this. All right. I'm going to do a little challenge to myself to see if I can do all of these steps we're going to skim over right now in under a minute and 15 seconds. And I want you to time me. We'll see. All right, but I want to show you how to do it first. So this is made-up variables, affectionately called predictor, moderator, and outcome, to make it as simple as possible. You can probably see how I made it up, 1 to 10, and then 1s and 2s for our moderator and our outcome. So, first step, theoretically, does it make sense? No, because they're not real variables, but in real case it would. Step 2, do we have enough power? Definitely not, there's only 10. But this is just an example. We've coded our moderator variable correctly as a 1s or a 2. Preferably that actually be 1 and 0. And then we're going to run our model. All right, so remember step 4 was standardize our variables. So if you click in SPSS, this is supposed to show you what to do, just like that other slides that I gave you in whenever we met last time for the conference. It wasn't August. October? Long time ago. You click Analyze, Descriptives, and then Descriptives again. Oh, I have a laser, don't I? I haven't used the laser yet. Then we click on the arrow to move these 2 over here. And if you check this little box here that says Save Standardized Variables, it's going to create 2 new variables for you at the end of your variable list. They'll the same variable name, but they have a capital Z in front of it. See how that works? So if you call this variable co-parenting, it's now capital Z in co-parenting. All right, with me so far? So that's how we standardize it. Hey. All right, and then we're going to compute an interaction term. Literally click transform, then compute variable. Up here we're going to give it a name, and I like to give the name something that's really obvious so I know what predictor and what moderator variables included in it. So Z predictor, if this was co-parenting, I call it Z mother, ZM cop for Z mother co-parenting times whatever this one was over here. Make sure it's clear in your title. Then we click, we move them over here from predictor into this box multiplied by the moderator. And we've got our interaction term now. We press OK, and it will be right here. And now we have everything we need to test our moderation. Our predictor, our moderator, and our interaction term. And the variables we're going to actually use in the model aren't these 2. The unstandardized, we're going to use these here. The standardized, these 3 will be what we enter in. And then we'll run a regression. We'll click Analyze, then Regression, and then Linear. There's several other options here for regressions. It goes down further. But there's binary logistic if your outcome is dichotomous, yes or no. Multinomial if there's several outcomes that are categorical. We move our predictor and moderator variable into this box here, and our outcome up here. And if you don't have to do it this way, but if you click Next for block 2, you can add your interaction term either right here in block 1, or you can click Next, and the second box will come up, and you can put it in block 2. And the point of doing it this way, which again is it's up to you, but you get to see if that interaction term explains significantly more variation beyond just what was there before and by the main effects. Options here, click for the R² change and continue, and then OK. And we'll get our output. Our R² is really high with this fake data I made up. It's almost perfect, only one number is off one. All right, and then our output, the ANOVA output, we don't actually report. It's a really great way to show that you're a student and you're not sure what you're doing yet when you report the ANOVA output in regression, because nobody ever does. It's the same with the adjusted R², for no one ever does except for master students and theses. So separate yourself from them, don't report that. But what we are going to report is our predictor, our standardized predictor, moderator, and the interaction term. The significance column, they're all significant, less than 0.05 here. The way we interpret these main effects, so remember we standardized them, so we'll say a 1 standard deviation unit increase in the predictor is associated with a 7.86 raw unit increase in our outcome. Raw meaning it's not standardized, it's on whatever scale the outcome is on. All right, these are our important parts here. Do you have the internet?
Right now?
I'm on Facebook right now. I don't even know what we're talking about. That's true. If you could Google this, Jeremy Dawson interaction figures. I found this website a while ago, and it was super helpful, and I want to share it with you. But you can make an interaction figure of any kind of model you want from this one. So I still just Google Jeremy Dawson interaction figure, and that first one that pops up, you come to a page that looks something like this. So you have lots of options here. You can have unstandardized. If you didn't standardize it like we just did to turn them into z-scores, you click the unstandardized. If you standardized it like we did, we'll click this two-way standardized. If you ran a Poisson regression with the count variable, you see where there's the Poisson further down. There's three-way interactions further down. So this handy-dandy little website is made by a stats professor who, I use this all the time, and I point our students to this all the time, and I just think it's super, super helpful. So if you click on that, were you all there? Can you click this two-way standardized? And I'll help you make a figure. If you've never made an interaction figure before, you're about to do it. Congratulations. Kind of a special moment. It's like a coming of age. Should have a party with the Frisbee. Okay. So does it look kind of like this? This is how it was defaulted on mine when I downloaded it. We're going to change these two words up here. Where it says ID, we're going to put in the names of our variables. Where it says these numbers here, we're going to put in our output. So here is our output right here. You can actually just leave ID and moderator because this is a variable called predictor and moderator. But if you leave those in here, the constant, 32.503 is our intercept. We can put that here where it says intercept or constant. Our predictor, 7.861. We're going to put that right here in the independent variable box. Independent variable on row 10, column B. And then for the moderator, line here, we're going to use our moderator output. These are our unstandardized betas, cut off at the top. And our interaction term here, our beta for the interaction term we'll put here. I think yours actually is on a scale of 1 to 5. If you wanted to right-click or left-click here within this figure, where the numbers are, you can change your axis to be, instead of the lower bounds and upper bound being 1 and 5, you can change it to 15 and 55, and you'll get something that looks like that. Does everybody see how this can work? So handy. You copy and paste this figure into your PowerPoint presentation. I've published several papers now with this. You'll notice it if you're bored enough to look at my papers. So that you can see, like, recognize that figure. This is from Jeremy Dawson's page. And it is. There it is. Congratulations. If I was that fellow and Doxin was asking me how to make an interaction figure, this is what I would have told that person. Here's an easy way to do it. The hard way to do it, does everybody remember the formula for a regression? Y equals beta naught plus beta 1 times x plus beta 2 times x. And you put in you just use the regression equation to predict your moderator and your predictor at one standard -1 and at +1. And you can just manually do it by hand, and you can figure out what the predicted outcome is at one standard deviation low on predictor, at one standard deviation low on moderator. But if you don't want to do all that math on your calculator, just plug your numbers up here and it'll make it for you. All right. And testing simple slopes. So further down on that Jeremy Dawson's page, it shows testing simple slopes somewhere is one of your options you can click on. You'll notice this part here is the same up here. You can leave this as it is because the mean is 0 and the standard deviations are already set to 1. Here, this was actually, I had to use the data to come up with the variance of these things to plug in the covariances to put that in. But if we wanted to test the simple slope at this condition of where it's -1, where it's low on the moderator, and low and high in tests of moderation mean one standard deviation high, one standard deviation low. You can write in the number here, -2, and then it would be have 2 standard deviations high or 2 standard deviations low. I've noticed some people do that, where I'm pretty sure it's not significant at 1 standard deviation high and low, but it is at 2. Whatever. Test it whichever level that you want to, put in your sample size, and it'll tell you here if this p-value is less than 0.05, that if this individual slope here is significantly different than a flat line of no change at all. So we could talk about it when we test the simple slopes and labels like this is a significant increase, as they're increasing in the predictor, and the condition of the high moderator, there's a significant increase by this outcome variable. All right, you ready? I'm going to show you live. Somebody pull out a stopwatch. I want you to be able to see it happen. This is really easy to do, and I don't want any of you to feel, oh, not quite. I don't want any of you to feel like this is something that's beyond what we're capable of, because this is something we can all do. All right.
Which time?
Can we see okay?
You got one?
All right. So if I want to test, this is a paper we published a little bit ago, but this is the simplified part of it. This is real data now. This is Fragile Families data, limited down to 848 couples across a few years where they are first-time parents. And we're looking at co-parenting when the baby is 1 year old, and their parental stress when the baby is 1 year old to predict relationship quality when the baby is toddler, 3 years old. Sound good? So the first steps we're going to do is standardize the predictor and moderator, then we're going to compute an interaction term, and then we're going to run a regression. You ready? I'm nervous. All right. Say go, whoever has it.
Oh, sorry. Started you already.
Well, reset it.
Oh, sorry, say it again. On your mark, get set, go. So first we standardize it. So we'll move mom's co-parenting over, because we want to see if the co-parenting can moderate the association between parental stress and relationship quality. So I've got those two Z's now. I'm going to make a new variable, mom stress times mom co-parenting. Co-parenting multiplied by mom stress. So now I've got the variables I need. Then I run a regression. Mom's relationship quality predicted by the main effect of stress, co-parenting, and that interaction effect. And there it is. What time is it?
50 minutes.
Whew. It can be done in under a minute. All right, so this is a commercial break kind of thing. So we can do this, right? So if we're looking at our output, we've got our betas here. So first off, my main question, oh, go ahead.
How did you measure co-parenting?
5 items in the fragile families. It's really actually not a very good measure. It's mom asking about whether or not she can trust dad to help dad take care of the baby.
Okay, so I use that, the Friday family data, and yeah, that's all that's been, it's a lot. And then so, yeah, but
Yeah, no, it's not a great measure of co-parenting. But it's something. It's mom's perception of whether or not she feels like she can rely on dad to help raise this kid. Yeah, good point. It's crummy. So we have a main effect here of co-parenting significantly predicting. Stress does not. The direct effect of stress, mother's parental stress to mom's relationship quality is not significant. The interaction term here is significant. So we would say that the co-parenting does moderate this association between mother's parental stress and mom's relationship quality. It's hard to make sense of how. I also see this happen a lot, where once we see this significant interaction effect, we just sort of make up how it moderates it. So thus we know that moms who have really supportive dads are doing better. But we don't know that until we plot the interaction figure. When we plot the interaction figure, then we can look to see what conditions of high and low co-parenting and stress were how they're doing. So can you see how we would make our figure for this? So our intercept and our 3 betas that we would plug in, and that would be it. I believe you could probably plot that in about a minute as well. So this whole thing could be done in a couple of minutes if you want. You would probably have more control variables and things in. But how's that feeling to test moderation? You feeling okay? Standardize it, compute an interaction term, run it, interpret it with that figure, use the figure, and then we can also report on the simple slopes to see if each of these lines is significant. Feeling all right? We move on, like moderation, check. On my life to-do list, learn how to test moderation, total success. All right. So let's go into a couple other quick things on moderation, and then we're going to test mediation. So you recognize this is an AMOS. See the same sort of thing? Predictor, moderator, using those same 3 variables to the outcome. We would interpret this in the same way. This is the output from SPSS. This is the output from AMOS. It's exactly the same, and it always will be if there's no missing data. If there's missing data, then the one in AMOS and M+ is more accurate. We were going to do it in M+. We can also draw a pretty picture if that's how we like to do it, or you can just write your model syntax out. Outcome on, and then put the 3 predictors there. All right, but in M+, when I ran it with the 10 people, it didn't like it, spit it back out like, what are you wanting me to do with only 10 people? It said it couldn't do it. All right, any of you familiar with McNulty? It's one of those superstars that should be a CFT, but it's doing our research for us. But anyway, it's really good stuff. I just wish that it said Alex or somebody in our field doing good couples work. When positive processes hurt. Can you tell from even the title of the article, what do you think he's researching here? Moderation, mediation? It's moderation, yeah. When positive processes hurt, when good things might actually hurt us. So he has this data set he gathered of a bunch of newlyweds he followed for 5 years. Let me skip down to here. So he's saying doing couples therapy and trying to help couples to be nicer to each other isn't actually working out super well. Lots of the time it doesn't work. So he's like, why might that be? So he tested starting here where it says specifically, you probably can't read it back there, but specifically, let's start here. Consistent with limited effectiveness of such interventions, however, findings from 4 independent studies of newlyweds indicate that positive processes may not only fail to help distressed couples, they may hurt them. You hear the moderation in there? Positive processes may not only not help, but may actually even hurt them. Specifically, although more positive expectations, more positive attributions, less negative behavior, and more forgiveness most effectively maintain satisfaction among spouses who are facing infrequent and minor problems. So the moderator is infrequent, how frequently the problems are and how severe the problems are. Although doing these nice things help in the context of when it's not severe and when it's not frequent. In the context of more severe problems and more frequent, it's the opposite. It's less positive attributions, less forgiveness, less kind behavior. Those things are predicting better outcomes for these couples. Isn't that interesting? Sitting in the trenches with them, you don't always want to tell a couple to forgive the partner, do we? Sometimes it's not all the best. Well, we could just forgive and move on, let bygones be bygones. So we cheated on you with a lot of other people. That happens. Let's forgive. Sometimes it's not helpful to forgive right away. Sometimes it's not helpful to make positive attributions of, oh, I'm sure he didn't mean to. We want to understand the context of when these things would be more helpful. This is also McNulty, bless his heart. Don't look at the future slide. Oh, we just did. Try not to look. Neuroticism is very robustly associated with marital satisfaction. If you have one partner that flips out in an intense, emotionally reactive way frequently, the partner is not very happy. It's just kind of one of those things. It's kind of reliable. So what might moderate this association? What could be good enough that could balance out a partner who is frequently flipping out in intense, dramatic, passionate ways? There's lots of things, but he tested one. But what are some things that as a therapist would like, this might moderate that and make this better?
Sex.
I didn't look, I swear, but that's it.
Yeah, it is. Sex is the one that he picked. There it is. So if their partner is pretty intense, flipping out all the time, but they're having a lot of sex, they're still okay. They're still, all right, interesting, isn't it? Can you think about it, though? There might be a handful of other things. I mean, to me, this is really relevant when you're working. I was just talking with a friend who's had problems with his wife, who is more on this neurotic extreme, how she reacts to most everything. But we need to know what can be helpful in that context that he's in. It's a real situation that he's in. What can moderate these expected effects of him being miserable and the relationship ending? What can moderate that? What can change it? There's more than sex, but that's what he tested. So let's look what he found here. You could see this intercept, neuroticism, sex frequency, and the interaction. We could plot our own figure from this as well, couldn't we? He computed an interaction term in just the same way we did, except he didn't standardize them. It's out here by the... But anyway, this interaction term is significant, this 0.18. So we can plot it. And we were plotting it as a line graph. You can also plot it as bar graph. Let's look at here. Not surprisingly, neuroticism was negatively associated with reports of satisfaction. Makes sense, right? More neurotic, less happy. However, as predicted, that main effect was qualified by a significant positive interaction of these two. It's qualified. It's another fancy word for moderation. Is qualified. This association was changed by sex frequency. What I think is most interesting about this, sorry, I went through a phase where I just read everything McNulty wrote because I just thought, man, he does good work. He does really good work. We need more people like him. But which group is the happiest? Who's got the highest relationship satisfaction? Say it real loud, Caitlin.
Low neuroticism, low sexual frequency.
Yeah. So if you've got a couple that comes in and they're pretty laid back, chill people, then I feel bad that we hardly ever have sex. Like, is there something wrong with us? Like, we're pretty happy and content with our life, but maybe we're weird because we feel like everyone else is having more sex. They might, and remember, low means one standard deviation low on both of these. So it's not near the average. They're way lower than the average. So way lower than the average on sexual frequency and neuroticism. That's actually our happiest group of newlyweds. Interesting, huh? In this context of high sex frequency, there's almost no difference on the relationship satisfaction if they're really high in neuroticism or really low. And you would feel it. If you're in a relationship with someone who's highly neurotic, you can tell. It's going to affect most everything, but if it's really high or really low, they're about the same level of relationship satisfaction. If they are way above average in how much sex they're having. Isn't that interesting? I feel like if we had way more studies like this, it would be really, really helpful for our whole field. I mean, it's just stuff like that. I just want to know because it's helpful for me. Do you tell your clients about research?
Yeah.
I do all the time. I think it's really helpful when they're talking about stuff like, oh yeah, do you know how normally does it? It's helpful for us and it's helpful for them. All right. This is a serious no-no. When you're a writer, when you're a reviewer, as a human being in the academic world, these words only apply. You can only use them. They are only correct if you tested an interaction term, and that interaction term was significant. Has everyone got that? As a reviewer for JNFT, people break this all the time. We try to, too often, we try to talk about our results in the way we want to talk about them, not in the way that we tested them and what we actually found. And that's a serious problem because it's super misleading to good therapists who are actually reading our research. We think that it has some meaning that it doesn't really actually have. So if we're going to say buffers the effects of, it had better first been a significant interaction term that we plotted and we saw how it buffered. Is a protective factor, exacerbates the effect of this, depends on the levels of this on the moderator, the relationship is qualified by this, it's stronger for this group than for this other group. Those things all imply that we tested an interaction term. If we didn't test an interaction term, please don't use this. Another thing, even if we sort of understand what mediation and moderation is, for JNFT, I'm at least over a dozen, I'm sure, of articles I've reviewed where I believe they wanted to test moderation. The language they have in the title throughout the entire paper is this is a protective factor for this. And then they'll test it as a mediator of A predicting B, B predicting C. Do you see what's wrong with that? To be mean, but a lot of the professors in our field aren't quite clear on that. But I want you to know. I want our next generation to know and to be super clear and to be super solid on if I want to test if this buffers as a protective, if it does these, I have to test that as an interaction term. I can't test it this way and then talk about it as the language I should be talking about a moderator. If I test it as a mediation, the language I use is this predicts this, and this predicts that, and that predicts that. It would be really wrong, and it's really a lie to say this protects, this reduces the risk of, this helps for the. It just means this predicted that, and that, just like the Frisbee from here to here to here to here. So please, with your buddies, if you see them slip into that when you're drafting papers, help them. Edit them out. When you, as a reviewer, please don't let any more things get published in JNFT where they wrong. Honestly, it actually frustrates me. I try to stay calm as a reviewer, but like, you totally tested the exact wrong thing. And you're talking about it wrong the whole way through. And shouldn't be that way. If we understand what mediation and moderation are conceptually, then we can think about which one should I test it as. If it's a moderator, I'm going to test it as an interaction term. If it's a mediator, indirect, I'm going to test it indirect. And if it's moderated mediation, I'm going to do it this or that way. Just make sure we use the test that fits the question that we want to ask. And then we use the language throughout our paper that matches the test we actually did, not what we were hoping that it did. Unfortunately, no one does this intentionally. No one's trying to pull the wool over people's eyes. Our field is full of really nice people. No one would ever do that. They just honestly don't know. So if we can all help each other run stuff, help each other interpret it, it will go better. All right, mediation now. Let's see. I think we can do this. It's going to be possible, I think. All right. So mediator is the stepping stones, right? So switching gears. Is everybody with me? Moderation is left back. We're moving into mediation now. So mediation is the stepping stone. A predicts B predicts C predicts D. Mediation is the mechanism by which one variable affects another variable. It's that process that happens that got us from the first floor to the second floor. mediator helps us understand the connection between two variables to a greater extent, in more detail and depth of how they're linked, how they're connected. I think that's good. Theoretically, we believe the predictor causes the mediator, and we believe the mediator causes the outcome. Statistically, how we're going to test it, it's always going to be either associated, but theoretically, we're thinking what causes this and what causes that. The same thing, just because we want it to be causal, all we can actually say is they're associated, that they're linked. This is super important to me. How many of you, when you do your lit reviews, you read a bunch of lit reviews and their articles that say something like, when Alex studied this, she found a positive relationship between co-parenting and relationship quality. However, when Evan studied this, he found a negative association between it. And when Carmen studied it, she found no association at all. Does this sound familiar? And now I will study it, and my results will tell you if it's positive, negative, or zero, because this is now the one. Those others, they were not the one. This one is the one. Does that sound familiar? And it sounds compelling when I'm reading it. It's like, oh, good. Glad we're finally going to know which way it works. But then Gerard publishes on it, and he finds something totally different. And like, wait, so whose is it? Who's actually right? Are they all wrong? Or when you hear that, can you have your little moderator red flag go up? And like, moderator, there's a moderator here. Nobody knows what it is yet. But there's been 50 people that have studied just the direct association of this and that. We could do 200 more of those and we wouldn't be any further ahead. One beautiful, nicely designed moderation study could really just open the floodgates of, oh, it depends on this, if it's positive, negative, or zero. That's what would be helpful. That's what can move us forward. We don't need another X and Y are linked. We need another Y or X and Y